Europa, one of Jupiter's moons that is not in the Goldilocks zone, stays warm. Jupiter and the moons that orbit around it are actually sending energy to Europa. Astronomers have been interested in Europa, Jupiter's interesting moon, for a very long time. From the time it was found in 1610 until the Voyager trips in the late 1970s, there were hints that there might be an ocean below the ice. It took decades of research and study for the James Webb Space Telescope to make its amazing 10-hour view of Europa. What hidden things did this long study show? Could it show that there might be life beyond Earth? What kind of sign is this? Watch as we look into how the Webb Space Telescope looked at Europa for 10 hours and then saw what might be a sign of life. Europa is one of more than 90 moons that Jupiter has. It is the sixth moon that is closest to Earth. Io, Ganymede, and Callisto, Jupiter's other three largest moons, were the first moons found outside of Earth's orbit. The Galilean moons were found in January 1610 by an Italian scientist named Galileo Galilei, using a telescope that he made himself. The surface of Europa is mostly made up of silicate rocks, and it probably has an iron-nickel core inside the water ice. The air around it is pretty thin and mostly made up of oxygen. There are dark, reddish-brown cracks all over Europa's water ice surface. The moon's surface doesn't seem to be more than 40 to 90 million years old based on the few craters that have been seen. This is very young in geological terms, that's for sure. Under Europa's icy surface is an ocean of salt water about twice as big as the ocean that covers Earth. So, they thought that Europa might be one of the best places in our solar system to look for life other than Earth. Scientists believe that the salt water below its frozen shell holds twice as much water as the world's oceans, and may even contain chemicals that are needed for life. A possible situation from decades ago was put forward in science fiction. What if life from other planets thrived in an ocean below Europa's frozen surface? Europa went from being unknown to being the center of attention because of this idea, and it has stayed there. People inside and outside of science are getting more and more excited about the idea of finding life beyond Earth using this information. That dream, on the other hand, might be based in truth. Spectroscopic studies done with a telescope at Kitt Peak National Observatory in Tucson, Arizona in 1972 showed that most of Europa's surface is made up of water ice. Thermal models from 1971 also showed that Europa may have a layer of liquid water in its center. Early in the 1970s, the Pioneer 10 and 11 spacecraft flew by Jupiter, but it was the Voyager 1 and 2 spacecraft that took the first high-definition pictures of Jupiter's moons. From a distance of about 1.2 million miles, 2 million kilometers, Voyager 1 came very close to Jupiter on March 4, 1979. The satellite took a picture of Europa from all around. A few months later, on July 9, 1979, Voyager 2 flew by Europa very close. Images from the two Voyager probes showed a surface that was brighter than the moon's and had many bands and ridges across it. There were no big impact craters, high cliffs, or mountains on it. We could also say that Europa has a very smooth surface compared to the other ice moons. Voyager pictures only showed a few impact scars. These are thought to form over time as meteorites hit the surface of a planet over and over again for billions of years, until the surface is full of craters. Since there were no large impact craters, it was thought that the moon's surface was fairly new and that the craters had been removed by something, like ice volcanoes or the icy crust settling under its own weight. These amazing finds made people even more excited about NASA's Galileo mission, which took off in 1989 and reached its orbit around Jupiter in 1995. Galileo's main job was to fly by each of the 4 Galilean moons many times. Because the information Galileo sent back about Europa was so interesting, the project was extended for a second journey that would last 2 years and be called the Galileo Europa Journey. The rocket went very close to the icy moon 12 times. Galileo's most important findings showed that Jupiter's magnetic field had changed in the area around Europa. This clearly showed that a thick layer of an electrically conducting fluid below Europa's surface is making a certain type of magnetic field. Scientists think that the most likely thing that could be causing this magnetic signal is a huge ocean of salty water. Based on what's in Europa's ice, its shell is 10 to 15 miles, 15 to 25 kilometers, thick and floats in water 40 to 100 miles, 60 to 150 kilometers, deep. Even though Europa is only a quarter the size of Earth, Its ocean may hold twice as much water as Earth's. The water around Europa is one of the best places in the solar system to look for life other than Earth. During Galileo's visit to Jupiter in the 1990s, no plumes were seen. However, newer observations from telescopes like the Hubble Space Telescope and a reanalysis of some Galileo data have shown that Europa may have thin plumes of water that are thrown 100 miles, 160 kilometers, above its surface. In November 2019, a group of scientists from around the world led by NASA announced that they had found water vapor directly above Europa's surface for the first time. A spectrograph at Hawaii's Keck Observatory found the vapor by looking at the chemicals in the atmospheres of other planets by measuring the infrared light those atmospheres give off or take in. If the plumes are real and come from Europa's ocean, a spaceship could go through it to collect samples and study them from space, which would be like studying the moon's ocean. This was done by NASA's Cassini probe on Enceladus, Saturn's moon, which is thought to have an ocean that shoots out into space. In order to keep exploring, the James Webb Space Telescope used two main tools to look at Europa, NIRCam and NIRSPEC. The near-infrared camera, NIRCam, which is James Webb's main camera, is NASA's replacement for Hubble and Spitzer. Its main job is to take very clear pictures in the near-infrared range of light. NIRCam has two parts. One is for wide-field imaging and the other is for coronagraphy, a way to block out the bright light that stars and planets give off and show things that are fainter in the background. NIRCam collects light from the first stars and galaxies, as well as stars in close galaxies, young stars in the Milky Way, and objects in the Kuiper Belt. Its wavelength range is from 0.6 to 5 microns. Astronomers can use NIRCam coronagraphs to take pictures of things that are very dim and close to a central light source, like star systems. Coronagraphs on NIRCam work by blocking the light of a brighter object so you can focus on a close object that is less bright. This is similar to how raising your hand over your eyes in the sun lets you focus on what's in front of you. Astronomers plan to use coronagraphs to find out about the properties of planets that circle stars close by. The near-infrared spectrograph, NIRSPEC, on the other hand, tests bands between 0.6 and 5 microns. A spectrograph, which is also called a spectrometer, is a machine that turns light from an item into a spectrum. The spectrum of an item can tell you about its temperature, mass, and chemical makeup, among other things. The object's atoms and molecules leave marks on its spectrum that are unique to each chemical element and can tell you a lot about its physical state. Spectroscopy and spectrometry are two of the best ways to study the world because they can be used to figure out what these lines mean. Webb looks at a lot of very dim things like the first galaxies that formed after the Big Bang. It takes hundreds of hours for Webb's huge screen to gather enough light to make a spectrum. During its 5-year mission, the NIRSPEC will look at 100 objects at the same time, which will allow it to look at thousands of galaxies. The NIRSPEC is the first space-based spectrograph that can see more than one object at once. Concerning how close Europa's ocean is to its surface, Dr. Geronimo Villanueva stated, "I believe that question has been a major motivator for Europa exploration. This suggests that we may be able to learn some basic things about the ocean's composition even before we drill through the ice to get the full picture." Dr. Geronimo Villanueva is a planetary scientist at NASA's Goddard Space Flight Center. He studies life in space and looks for it on Mars, Venus, ocean worlds like Europa and Enceladus, as well as on primitive bodies, comets, and faraway exoplanets. He is the Assistant Director for Strategic Science in the Solar System Exploration Division. Aside from that, Villanueva is the lead scientist for the Comet Interceptor MIRIS instrument, a co-investigator for the ExoMars TGO mission, and the James Webb Space Telescope leader for study on Mars and ocean worlds. Astronomers have already used the Hubble Space Telescope to get early reports of plumes coming from Europa's surface. At first, astronomers used NIRCam to look at Europa while blocking out the light from Jupiter. This was seen on January 9, 2023, when Europa was about 10 hours away from Earth's closest point. James Webb's main screen, which is 6.5 meters tall, was lined up correctly with Europa. During this time, NIRCam and NIRSPEC both gathered information at the same time. The experts say that Webb did not find any plumes while it was studying Europa, but that does not mean that there aren't any. Heidi Hamel said, "There is always the possibility that these plumes are variable and only visible at certain times. All we can say with 100% certainty is that when we made these observations with Webb, we did not detect a plume at Europa. Hamill is an interdisciplinary scientist who works on the James Webb Telescope project. He focuses on Webb's topics of planetary systems and how life began. She has used the Gemini, Hubble, Keck, Spitzer, and other telescopes to study the outer planets of our solar system, as well as their rings and moons. As a planetary scientist, Hamill knows a lot about how to use Hubble to look at the solar system. She was in charge of the Hubble team that looked into what happened when Comet Shoemaker-Levy 9 crashed into Jupiter in July 1994, focusing on how Jupiter's atmosphere changed. Here is a deeper look at what the James Webb Space Telescope found on the surface of Europa. On Europa's frozen surface, scientists found both crystalline and amorphous carbon dioxide. Amorphous means that the form of the molecules is not organized, unlike crystals, which have solid patterns. Carbon dioxide is one of the most important things in the world. It is a gas made up of one carbon atom and two oxygen atoms. It is thought to be very important to life because it does things like breathing, metabolism, and photosynthesis. Plus, it's a greenhouse gas that traps heat and changes the Earth's temperature. They were first interested in where the carbon dioxide came from. Did it come from outside of Europa or from other places? Since it came from micrometeorites or other things outside of the Moon, it was pretty much the same everywhere. In this case, though, it was only in one place. Geologists think that this area is a new, chaotic terrain. This is very interesting because it means that something is happening below it. Today's question is how carbon dioxide got to the surface of Europa and why it's only there in one place. Most likely the carbon came from Europa's underground ocean, which is thought to be a possible place for living things to live. It is thought to be about 100 kilometers deep, and it has more water in it than all of Earth's seas put together. Water stays in the ocean because of Jupiter's tides. Europa's interior is stretched and compressed by its gravity, which heats and powers the planet and keeps the water liquid. In places, there is ice 10 to 30 kilometers thick between the ocean and the top. This ice isn't just sitting there, it's active and broken up, with cracks, vents, collisions, and eruptions that let things move between the ocean and the top. The carbon dioxide that was found could have come from a number of places, such as chemical or biological processes happening in the ocean and being carried by currents or jets. It could also have been dissolved in ocean water and released as gas or ice when the temperature or pressure changed. This spot on Europa, close to its equator, is where carbon dioxide was found. It covers about 12% of the planet's surface area. These cracks in the ice let things move back and forth between the ocean and the top. There are several ways that the carbon dioxide that James Webb found could have gotten to the top. It could have been broken down by ocean water and then come back as a gas or ice when the temperature or pressure changed. It could have also been made in the ocean by chemical or biological processes and then brought to the top by currents or jets in the ocean. The carbon dioxide was found close to Europa's equator. This area is called chaos terrain because it has a lot of different types of terrain, such as ridges, cracks, blocks, pits, domes, and depressions. Many people think that the ice's jumbled appearance comes from the way it interacts with the water below, which makes it melt, freeze, break up, and refold itself. This area is also one of the most busy and diverse geologically, which makes it a great target for Webb's sensors. So what does this find have to do with whether or not Europa's ocean is habitable? There may be organic molecules or living things in Europa's water because there is carbon dioxide on its surface. Organic molecules are molecules that have carbon in them. They are necessary for life as we know it. Biological action is any process that uses living things or things made by living things. The important thing about this finding is that it has to do with both organic molecules and biological activity. When carbon dioxide and water mix, carbonic acid is made. This acid can then break down into bicarbonate and hydrogen ions. The pH, acidity, temperature, and flow of the ocean may change because of these ions. It could also change the chemicals in the environment in ways that might help different kinds of life. This chemical compound can join with other elements or molecules to make more complicated organic compounds, such as sugars, amino acids, nucleotides, and lipids. These are the molecules that make up carbohydrates, proteins, nucleic acids, and lipids, which are the building blocks of life. They can also hold information or energy that living cells might need. Carbon dioxide may also be taken in or made by living things in the sea. It may be used as a source of carbon and energy by some bacteria through photosynthesis or chemosynthesis. Carbon dioxide was found on the surface of Europa, which could help us learn more about the ocean's makeup and how it moves. We can guess how much carbon is in Europa's ocean, how it changes forms and moves around, and how it combines with other molecules or elements. We can also figure out how it affects or shows different biological or physical processes by checking the amount, location, molecular makeup, and changes in time of the carbon dioxide on its surface. It could also help plan future trips to Europa. One of these projects is NASA's Europa Clipper mission, which will fly by Europa many times to learn about its rocks, atmosphere, and environment. Plasma monitors, cameras, spectrometers, radars, and spectrometers will all be on the Europa Clipper. It will also send a lander to the surface of Europa to study and make observations. It will use information from James Webb to pick the best targets and methods for its research. It will also test the idea that Europa's ocean is livable and look for signs of life. Scientists and people who like space are excited about two missions that are going up to Europa. The Clipper mission, which NASA plans to send in 2024, gives us hope that we can learn more about this strange moon. Its job is not only to explore, but also to carefully scan Europa from orbit. This expedition is a very important step towards solving the secrets of this very faraway world. In its orbital scans of the moon, it will focus on finding chemicals and conditions that are good for life. In the same way, the Jupiter Icy Moons Explorer, JUICE mission from the European Space Agency, which was launched into space in April 2023, shows a lot of promise as it gets closer to Jupiter and is set to arrive there in 2031. It will begin a long trip that will include 35 flybys. Europa, Ganymede, and Callisto, two more interesting Jupiter moons, will be involved in these carefully planned meetings. This all-encompassing plan for research sets the stage for a full study of the whole system of Jupiter. It gives us a new way to look at the wonders of these cold moons and may change the way we think about how life could exist beyond Earth. Thanks for seeing another video. Click the movie on your screen to see more videos like this one that will blow your mind.